router network top questions. So now let's start. Question 1. Consider a network uses CSMA MAC layer protocol, data transmission bandwidth this and maximum signal propagation time from one node to another node 100 and calculate the minimum frame size in bytes. So for this question I use this approach Tx greater than or equal to 2TP frame size upon bandwidth greater than. In this way I solve this question. For minimum size we take frame size. Here we calculate frame size from this and to multiply in 100 into bandwidth and then I get 1000 bytes. So in this way I solve this question. Now next one is consider a TCP segment sequence number field 1280 and it contains 1500 bytes as a payload. The acknowledgement number sent by receiver. First it takes segment sequence number 128 and after it transmit 1500 byte data, then what's its acknowledgement number. Then we calculate for its acknowledgement number first sequence number and plus data byte and then we get next sequence number 2780. So in this way I solve the second question. Now next one is consider a system with three network connected two router network. A has MTU 100 by 1000 bytes, network B has MTU of 500 bytes, C has MTU 700 bytes. Station has sent a segment of 680 bytes. So for this question I solve this way. First we see that MTU size is less than the frame size, so we we perform the fragmentation. 680 data bytes divided by 680 because it segment it given segment is 680 and 480 is MTU size. Why 480? Because MTU has 500 and 20 bytes header size, so we will take 480. Then it takes floor value, seal value, get 2. So number of fragment 2. These are the fragment. First one is 20 header byte data and 480 data bytes. 20 byte header and 200 data bytes. So at C node there is no further fragmentation because MTU has greater than data byte. So no need of fragmentation. So total byte transfer in this operation 20 header plus 480 data bytes for first frame and second for 20 header 200 data bytes, so total 720 bytes. So in this way I solve this question. Now next one is an IPv4 packet has the first few hexadecimal digit. This is the IPv4 packet header data. In IPv4 you know that IPv4 packet contains many of like version in 3-bit and header length and then fragment offset further. In last it contains destination address and source address. Destination address of 32 bytes and source address of 32 bytes. So it is in hexadecimal, so one digit is 4 bit. So I will take 32 bit from last because destination source address is in last. So 4 4 4 total 8 digit tag for 32 bits. So 1 2 3 4 5 6 7 8. There here to here it's source address. So I will put and calculate hexadecimal in octet form. So for octet form, we will take two 4 bits number and it will form octet. 4 bit and this 4 bit it will form octet, so it gives IP address in octet form. Therefore first octet it will ask for first octet, so first octet is 242. So in this way I solve this question. Now next one is, consider a 512 into 10 raised to power 3 bit satellite communication link with one-way propagation delay of 150 millisecond. Go back in protocol or use, and acknowledgement size is 64 and frame processing time is 5 milliseconds. Then what would be the minimum window size? So for minimum window size we take n, and this is the total delay and transmission delay of frame, and is equal to 1 for minimum. Put the value of everything: total delay, transmission delay of frame 32, and 2PD 2 into processing delay 150 and plus processing delay and progression delay and transmission delay of acknowledgement. Total 338 and divide by 32 because transmission delay, then it gives 10.56. We take seal value 11, so window size is 11. In this way I solve this question. Now next one is, of the following is a dump of UDP header in hexadecimal format. UDP, and this is the UDP header. We know that in UDP header, first one is UDP source address, second one destination, then total length, then header checksum. So it is given in hexadecimal. First we convert in decimal form. For source port address we take this 16 bit data. We get 25688 in decimal form. So source port number is 2566688 in decimal. For destination we will take this data 16 bit, and then after converting decimal form I will get 2598. So decimal port is 2598. So option A and B also correct. And the length of the data, for length of the data I will take this is total length, and if we minus header length of UDP data, so header length of UDP is 8, so minus 8 I will get this. Then the length of data will be this. So option D is also correct. A, B and D are correct. So now next question is, an IPv4 datagram is received by an IPv4 router. Header length field 10 and total length 2340 MTU of the link this. Then total number of IP fragment after fragmentation. So header size 40 byte, total length 2340, data header 23. So minus header length, so I will get data. It will pass through 100 by MTU. So after minus header size I will get 60. So 60 is not multiple of it, then I will take multiple of it. So 56 is multiple of it, so divide the data according to 56. So there are 41, total 41 fragment. In last fragment I will send 60, total 60 byte data. So in this way I solve this question. Now next one is, which of the following IP addresses may represent last host of any subnet if subnet mask is this? It will ask for last host if subnet mask is this. So after comparing all options, I will see that in option A, here is last host of second subnet I found, because in last there is 0, so it is last host. And option B is also last over third subnet, but C and D are DBA, direct broadcast address, because all bits are one. So C and D are not. Only option A and B are correct. So now next question is question 9. Determine maximum length of cable in for transmitting data of rate Mbps. So it is also solved by this method, Tx greater than 2 TP. After putting the value of Tx like 100 by data and by divided by bandwidth, so I will get Tx, and for TP L by speed. So after calculation I will get L is equal to kilometers. So option B is correct for this question. Now next one is question 10. Let Gx be generator polynomial used for CRC checking. What is the condition that should be satisfied by Gx to detect odd number of bits in either? So for this question, for odd bits number of error should be x plus 1 should be factor of Gx. Generator polynomial should be factor of x plus 1 for odd number of error. So in this way I solve this. Now next one is frame of 100 bytes are sent over 10 raised to power 6 Mbps duplex link between two hosts. The propagation delay, these frames are to be transmitted into the link to maximally pack them and transmit within the link. What is the minimum number of bits? So for this question I solved by this method. First we calculate Tx transmission delay from 100 by data and bandwidth divided by bandwidth, we get 1 millisecond, and TP 25 millisecond. Now it asks for frame size, so TP by Tx give frame size, so it gives 25 frame. For sequence number I will check which one is satisfied on putting the value in sequence I in power of 2. So if we put I is equal to 4, it will then 2 power of 2 2 power of 4 is equal to 16. If I is equal to 5, it will give 32. It will come under condition 25. So I is equal to 5 is correct. Option D is correct. Now next one is in Ethernet, when Manchester encoding is used, the bit rate is half the baud rate. So option A is correct. It is half the baud rate. Now next one is there are n station in a slotted LAN. Each station attempt to transmit with the probability P in each time slot. What is the probability that only one station transmit in a given time slot? So in this question we use binomial theorem. First, first station is transmitting and others are not transmitting, and if second condition is if second one is transmitting and first and other ones are not transmitting, and in third condition if third is sending and but first second not sending and others are not sending. So for this total n possible combination, P1 is sending and 1 minus P power of n minus 1 is not sending. So option B is correct for this question. Now next one is in a token ring network, the transmission speed is 10 raised to power 7 bps and the propagation speed is 200 meters microsecond. The 1 bit delay in the network is equivalent to. So for this question I will solve by this method. For 1 bit delay I will calculate transmission delay of 1 bit. It will give 0.1 microsecond. Then after 200 microsecond cross 1, it will give 20 meter as cable length delay. So in this way I solve this question. Now next one is the message 101 is to be transmitted using CRC. For this question I will solve by this method. 101 first we take generator polynomial and then add up to 1 minus 1 bit 0 in last of the message and then XOR operation perform. Then after get reminder 1 1, so I will add this reminder in last of the message, so then message will be this. So this message is correct, so option B is correct for this question. Now next one is question 16. Consider a selective repeat sliding window protocol that uses frame size 1 KB to send 1.5 Mbps link with a one-way latency of 50 milliseconds to achieve link utilization 60%. For this question, first we calculate Tx transmission delay. TP will be given 50 millisecond. Then this is the window size. For 0.60% we take 0.6 and then we calculate the value of window size. Gives I will take from seal value 12 will be given, but it is selective repeat, so 2n is for generating of sequence number. Take 2n because window size or sender side and window size of receiver side it will make 2n. So for 2n it will 24, so n is equal to 5. It will cover if 2 power of 5 is 32, it will cover 24, so n is equal to 5. Now next question is question 17. Consider a source computer is transmitting a file of size 10^6 computer over the link R1 and 3 links L1 L2 connects R1 and R2 and L3 link to VLAN. For this question I will for this question I will solve by this method. First we calculate propagation delay 1 millisecond and then transmission delay 1 millisecond. Time for first packet to reach the destination 3 TP plus 3 TX. 3 plus 3 is equal to 6. Now for total time we take first packet to reach the destination and then only rest packet only transmission delay of it, so it will total time is 1005 millisecond. So in this way I solve this question. Now next one is question 18. Assume that source S and destination D are connected intermediate router R. How many times packet has to visit the network layer? So network layer visit by the packet if it is start from source first time at source and then route at router one times and then destination one time, so total 3 times network layer. So option D is correct, network layer 3 times and data link layer 4 times. In this way I solve this question. Now next one is question 19. Data link layer is related to framing and network layer is related to routing. Transport layer is connection control. Presentation layer is connected to encryption. So option 4 is correct for this question. Option 4 is correct for option D is correct. So now next one is question 20. In an IPv4 datagram, the modified bit is 0, the value of h length is 20, the value of total length is 40, the fragment offset 300, the position of the datagram. Modified bit is 0, it means it is the last bit, it is the last fragment, but what is the its what last bytes of the payload and first byte? Sequence number of first byte. Sequence number of first byte is four. mm, Offset is 300, then multiply offset by 8, 8 3 are 24, 24 is the first sequence number, and then last byte of payload is last byte. Last for calculating last byte, we total length minus header length 400, 4 10 are 40, 400 minus 360 plus in 2400. If we 360 plus, uh, I will 360 plus minus 1, I will get 2759. So for this question, option C is correct. Now next one is question 21. ISP provider has chunks of CIDR available with it. The ISP want to give half of chunks of organization A and quarter of organization B. So which of the valid allocation? I will see all the options, but option B are overlapping, and option C is also overlapping to each other, and option D is also, only option A is correct. It does not overlap to each other. Mm, this is subnetting bit where 1 0 and 0 1, it does not overlap. So in this way I solve this question. Now next one is question 22. Suppose computer A and B have IP addresses this, and they both use the same network mask. So if and B should belong to the same network, which of the value and should not be used. So I will see the all the option A, B, C, D. In after comparing A, B, and C give the same network after XOR operation on the subnet mask with these IP addresses, but option D is not gives the same network because XOR operation of these bits gives another subnet number, so it does not belong to same subnet. Only option D gives, or remaining gives the same network. So for this question option D is correct. Now next one is consider the different activities related to email. Sending an email to mail client to a mail server. Sending for this operation we will use SMTP protocol. Download an email from mailbox server to a mail client. We will use POP protocol, and checking email in a web browser. We use HTTP protocol. So in this way I solve this one. And now next one is which of the following is the main function of the application layer in OSI model? Mm, for this question is providing network services to end user. Option C is correct. Providing network services to end user. These are the questions which are related to computer network, which are most expected and previous year question. Now, for later update, please follow, subscribe my channel. Thank you very much.